All right, yeah. So next up, we have Andrew with the TBD FS system. And there you go.
All right, Andrew Gibson, probably know me as Adventures in 9. Be doing the to-be determined file system, a database-like file system. That's in scare quotes because database-like will be doing a lot of heavy lifting here. I'm not actually a database expert, so I'm databasing without a license. So first off, what I'm not doing. This is not supposed to be some replacement for your typical hierarchical file system. So not competing with cache-warm file system or GFS. And even though a lot of people asked when I mentioned this, I'm not trying to port SQLite and have the files as blobs. So my initial inspiration for this was BeOS. I actually used the original BeOS Release 5 way back in the day. And their file system had some really neat abilities to have arbitrary metadata attached to it. So and that allowed you to sort files by that metadata and do what they called a live query. So as an example here, this is tracker. This was the standard way you viewed files in BeOS. And this would be your people. And you could, instead of just having name, modification date, size, you could put in contact name, work phone, and this would just show up as in your standard file browser. A thing to note here is that the size of these files is 0 bytes. So in the BeOS file system, they use kind of typical inodes. And the metadata was, if it was small enough to fit in the inode, you didn't actually have to have an actual file anywhere associated with it. One of the other things you could do is called a live query. And what this was is you could have a folder on the desktop, look like just a directory. What it was, though, is it ran a query every time you opened it. So if you ever made any changes into the background, every time you opened it, it would just requery the hard drive and bring it up. So in this case here, it's looking for anything that has this word server in the name. And this was nice for if you had a lot of MP3s, you could just dump them all in the folder, have the metadata, and you could make separate live queries for, does artist equal Pink Floyd? And it would just automatically show up in that folder. If you added more, you didn't have to actually do anything. It would just re-index all its own. So I want to do this in Plan 9, but first run into a little bit of a roadblock. In 9P we got stat, but we don't get arbitrary metadata. We get the standard mode, mtime, name, stuff like that. But what we do get is a lot of flexibility with where we can mount and bind things and a ton of software already written for making synthetic file systems. So what I want is the ability to go, look in my file system and get a list of directories, either to return what's in the, already indexed, the metadata for the files I have, a flat list of all the files I'm indexing. I do have this, which is mostly for debugging, where you can just walk a B+ tree. And then the double struct queue is for just running a query. So when you walk through the index, you'll get, right now my test case is basically a whole bunch of PDFs, all the Plan 9 papers I could get, a bunch of data sheets. And, you'll get, your attribute, so author, make, model, publisher. You could go put, an attribute and give it a key, say SPY, and that would give you back the values. In that case, it's just a bunch of data sheets that happen to have something to do with SPY. Or same with the one down below there for all winner. That's going to bring back anything that has attribute make, key, all winner, and then the values come back to the actual files that match that. Running a query basically gives you kind of the same output, but in this case, you're not like walking a tree. You actually have to put in the whole thing, and then it runs it and gives you back a result. So in the case of the metadata, you can go into the meta directory, and this is what is actually in the metadata. So the ones with the double struct Ps, right now I have that set up for when you originally run the system. You can point it at a directory. It will make a meta directory in there and generate text files corresponding to all the files you have in there, and it'll automatically enter the name and the length. Eventually, I'm going to have all the metadata, all the stuff that, stat expects to be put in here. That's when I eventually move to an on-disk version. But yeah, all it takes is basically you're putting in an attribute name, a type for it, and then the actual value. So for types, I got text, I got integers, which is basically corresponds to a signed 64-bit int. I have an option for number, which is an unsigned 64-bit int. And you can also do, I don't have an example, but you can do decimals, which will do double. So what I have so far is it runs on top of an existing file system. And it just expects basically a bunch of files in a directory. And it adds the additional meta directory that just holds plain text files. That's the metadata. So you can go in and just edit it by hand. So on startup, right now it's going to generate a unique ID for each file. Borrowed the word quid, but used a double struct queue for it. The reason for this is that I originally intended to do this on disk. I started doing that and quickly found out I was just trying to replicate ZFS, and the deadline was coming up. So I set that aside. The reason is I was intending to do copy on write for everything. I'd expect to have matching file names, so I had to come up with a unique way to name everything. So right now I just run a hash on the file name, the M time, and the length. So once I have the unique IDs, I build a hash table for that, and that points back to the path on the hard drive. It then reads the metadata and builds an index and the B+ trees for all the attributes. And when coming up with this, there's an excellent book just on file systems in general by the guys who made BFS. And one of the things they sort of lamented was that when they did theirs, searching through strings was a pain because while B+ trees were very fast, what they ended up having to do was just go all the way down to the leaves at the beginning and then do regex all the way across. So they kind of lost some of the speed. I cheat, and every string it'll tokenize on a space and just enter in the words individually. So you can just traverse the tree just on a single word that you might expect to be in something. So these are the structures I'm dealing with here. Tried to not have to do separate node and leaves. I'm trying to combine it all into one. So some of this here is just for debugging purposes, but I do have the attribute name for the node. The type is basically I just treat it as a bit field to hold a bunch of flags. So more is going to be, so when you go down the tree, it's just going to assume less, and it will go down the nodes here. If it gets to the end, it's just going to go more to the next. And then when you get down to the leaves, more and less will traverse across both ways. And then for the keys, there's my examples here where I have the available keys, either a string of S size, which right now is just sort of hard coded to be 256 bytes, and then the signed and unsigned and the double there. So the nodes, when it comes across that, it's either going to reference another node to go down and what key that holds, or if you get all the way down to the leaf, it's going to be a link, and for right now, that points to a quid. It'll go pull that from the hash table and bring up the file you're looking for. So initially when it starts up, I just build an index, so it'll go and just put everything in unsorted in one of the attributes. So it'll just start, so for make, it'll put all winter, rock chip, just fill it out. And it does that right off the bat. Afterwards, it goes and builds a tree out of that. And rather than have the typical display of like a whole bunch of boxes with lines connecting them all, I just decided to demonstrate walking through it. So if I go into make, if I want to look for all winter, this thing goes by less than, so it's less than Noritake Itron. I get another listing. All winter is going to be less than a Theros. And when I get down to this one, you'll notice there's that more, which corresponds to the more on the NDB node. Once there's no node, I'm actually down to the leaf area. So I did try to put the mores and the lesses in here, but when I first did it, I was building it like a prototype version using a crate file. And so that actually builds, the file system in memory. I was like, why not? I could do this. And I did it. And then I fired it off and I watched my memory fill up. because it would traverse back and forth across the lesses and mores the whole way. And so I haven't gotten a chance to put those back in yet. I'm not doing that anymore. I should be able to do it. But for now, though, it's a clue that I'm down now to the leaves. So once I read the leaves, that just gets me files. So future plans, now that I have a rudimentary thing working, is some sort of query language. The BeOS one was very kind of C-like, you know, use ands and pipes and stuff like that. A lot of people have asked, like, do SQL, and I'm like, no, I don't have that much longer to live. But yeah, something. There's also LISFS, LISFS, where they came up with an example, very similar system where they built it into the path, so it looks like a path. So that way you could feed it to any other program that expects something that looks like a path. Problem with adding a lot of ampersands and pipes is like, well, RC already looks for those, so you have to escape them all out. So pros and cons to a few different options there. A method to mount a specific query, because again, what I'm looking for is to replicate what I could get away with BeOS, which I really liked the live query thing. I liked having a bunch of files somewhere with metadata, and I could make a folder that would just organize them for me. So either something like this, you know, the specification option on mount, or also options to do something like replicate a you know, clone file that you see in a lot of things, where you could, you know, put a query into a file and it would just produce a new one in that directory. Of course, I want to do this on disk. You know, my point is I have a whole bunch of PDFs, music, images. I'd like to also have a nice file system that's meant to just for archival storage. But also a lot of other people have liked what I've done so far, and so I probably am going to keep the overlay option. You know, what I got was, you know, to help go through and organize your emails. Well, you probably already have your emails stored somewhere and don't want to move them to some other special hard drive or partition, so, you know, keep the option to do it as a overlay. So I did manage to get it up in a mostly working state. You can download it and play with it. And I also have it running here. So I can do a quick demo of some of the stuff it does. So I can fire it up. I can point it at a base directory. Oops. Oh. Should put a space there. So now it's just going to mount itself in TBD FS, or TBD and TBD. So like I said, pool will just list all the files currently just in the pool. So here's just all the raw PDFs. You can just go through them that way. If you look in Meta, so it'll give you the same exact file names. But in this case, if I look in them, so if I do this one here, it's just going to give you the metadata that's in there. So can't currently edit it from here. That's definitely something to do in the future. But you can see how, like, you know, a title, text, the ones who walk away from homeless, you know, the years an integer, page count is a number. And so if I wanted to, like, query that sort of stuff, I could either, you know, just walk through the index where it's like, well, if I know who the author is, you know, I could look for, let's see, Le Guin. Oh, scroll too fast. I still haven't gotten used to how the wheel works on this thing. I don't know if I ever will. But yeah, I can search just manually. If I have like an idea, I could just actually browse the whole thing. I could go and just, if I'm curious, I can be like, well, what has, actually talking to someone about this at break, what has the most pages? Somewhere in here, I think I have something that has like thousands.
6407.
Is there 6407? Oh yeah, there it is. And so if I want to, I can be like, well, what the heck is what has 6407 here? Oh yeah, it's my it's a data sheet for IMX, and I do have it set up so if I want to, I can go ahead and read right out of here. Actually, this will probably take a second to load up since it is a 6,000 page data sheet. Maybe that was a bad example, but I'm definitely torturing it here. So this is all running right now in QEMU. I got 2 cores, 2 gigs of RAM. So as you can see, this thing doesn't really use a whole lot of RAM, even though it's currently building, the whole index and all the B+ trees in memory. So eventually, yes, I'd like to get this on the hard drive, but for now, this is all running out of memory. So you can also do things, like I said, you could do queries, which will do a direct one. So let's say I want to do, I'll make this a little bit more fun. I can do TBD. I can query for anything that has Thompson in it. And I'll mount that to my demo directory. And then I could also add, so right now I'd like to eventually have some sort of query system where I could do ands and ors and all that sort of stuff. Also the numbers, I should be able to do ranges, anything that was made after 2005 or something. So a greater than, somehow process that. But for now you can do sort of a cheap one where again you can use mounts and binds. Demo. So then when I look into, how do I do that? It's put all those in there. So I can see I have obviously 2 files for 9. If I look in that, that's probably going to have both Thompson and Pike as authors on it. So if there's Pike, there's Thompson. So yeah, that's basically the idea, is to have just sort of like a database interface for your files as a way to organize it. So hopefully that was interesting and everyone had fun.
It looks like we got questions.
So you're talking about live queries a lot. How do you handle actually updating the index how do you handle updating the index as new data comes in?
Right now I don't, because it's all, running on someone else's file system. It's all running on GEFS technically. So it doesn't know that anything's changed underneath. So right now you'd basically have to kill it, change your metadata, fire it back up, and it'll read it in fresh again. So one of the things I'd like to do, again, getting it on disk, it will know when something's been changed on disk, and then could go trigger a re-indexing event to put all that back in, redo the trees as necessary, and then it should just work when next time you read it.
First, I noticed that we're now at the second Ursula K. Le Guin reference for the conference. We're at one a day, which I think is probably under quota, but I appreciate it. So you talked about getting it on disk versus it's in memory now. Are you storing the metadata on disk somewhere? Is that
the metadata is on disk.
Can you show just what that looks like?
So that would be in TBD FS. So this is the directory that I just have all the PDFs in. In that directory, there will be TBD01. In there will just be a directory called meta. And in this case, when it builds it, so this is actually generated by the file system code right now. There's sort of 2 modes you can start it off with. With the B flag, that's saying this is my base I'm building off of. When you're starting, you use an S flag pointed at a directory, and it will go through, make a meta directory, and in there generate, the same name but with a .meta at the end. So right now I have to do all this by hand. I actually just found out yesterday that there's a lib tags that I could use to pull ID3 tags out of MP3s. So for something like that, you could then run another program that runs through MP3s, script it up so it writes into these files, and then you could have all your MP3 files sorted out that
Like
way.
attribute value, like what are those attribute value pairs?
Yeah. They're just text files. So if we go back, so I demonstrated where it's like when I read it out of the thing, it looks exactly the same here. And so right here is where I'd edit it. So I had to do all this by hand. PDFs do have an option to put in data that you can pull out, like ID3 tags. No one uses them. So I had to go through and do this all by hand. So right now, yeah, this is where I edit the metadata, and then it reads it from this when it fires up.
Thank you.
Question from Synap.
Oh.
Can you show an example of the indexer?
Like in action, or
I guess how do you generate the index?
how I generate it?
You said there was another mode.
For the index. Well, it does. Right now, when it fires up, it runs through. I allocate a TBD node for the attribute, and then that has links, pointers to other TBD nodes. And so each of those will show up as a key for that. And so the index, that's kind of what I get when I walk the index on this thing.
I think what he was getting at was reading the rest. Sorry. Reading the rest of the thing. I think he was asking the wrong question. And really what he wants to understand is how would you do your own custom indexer?
How do I do it?
Like, if I wanted to, say, index a different type of file that you hadn't built into
a different
TBDF.
type. I mean, I do have it hard-coded for like strings, integers, and stuff like that.
What if you wanted to build an index of source files by function name, for example?
Oh, so one of the things I did try to do is leave it open-ended. Let's see here. Right there. So in this one here, where I have the leaves, and this is coming from talking with some other people too, I had some really wild ideas about hypertext stuff. I do have a type for my link. Right now the link is the quid. It's the unique ID to a file that points to somewhere on the hard drive. A lot of people were like, well, what if I could point to a URL? Or what if I, instead of a link to a file, it then links to basically another node that's associated with that file. So if I go to the end of a leaf and I pull up Ursula K. Le Guin again, it might also, in there, have directories, nodes, to other things associated with Le Guin, like other books or something. So I did leave some space in there to do other things like that. Again, my thing was like, I'm just trying to organize my PDFs. And I mentioned this to people, and they're like, what if it could also, And so I was like, well, I'll think about that, and I'll at least leave some space in there. So yeah, these 64-bit ints, 64-bit system, I'm only using like 2 or 4 bytes out of it. So you could, actually the nodes I did leave some space in there to use big blocks of magic numbers for doing stuff on the hard drive, so I could scan through later and make sure everything's lined up. But and yeah, the reason I have these maxes on here is I did set them up to fit within 4K for both page size and blocks, so they are sort of limited. If you get too big, it'll overflow, and it'll use the more to just make another node if you need additional space.
All right, looks like that's it. So thank you very much.